Hi, this is Miss Harder, and I'm actually going to go over some of the lessons from yesterday for 1.2.1 proportional relationships and graphs. So when you're looking at 1.2.1 with proportional relationships, they are going to want you to graph each one of these. Okay, so first off, you're going to need to put an X and Y table. Remember, we did this a little bit last week, right? We're going to need an X and Y table, and then two, we're going to need a graph. Perfect. So with 1-41, that's pretty much our main problem, and it's got several different problems within it. But I'm also going to talk to you about 1-42. Now, a proportional relationship usually starts out with a fraction. You could do it as a fraction as well. A fraction. Also, another thing that you should know is that a proportional relationship, when you look in the X and Y table, never has anything in the 0 box. Like it doesn't have 5 here. You know how last week we were doing 0, 1, 2, 3, 4, 5, and we'd have like something in this moment, and then we'd be able to do a start with our y equals mx plus b. In a proportional relationship, it always starts through the origin. And 0 and 0 in the X and Y table. Okay. So let's start out with 1-41. And the first one says, Parvin often cleans the dishes for her mother. She can clean 17 dishes in 10 minutes. How many plates can she clean in different amounts of time? So for A, I'm just going to make an X and Y table here. Boom, 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 boom. And I'm going to put 0, 1, 2, 3, 4, 5. And then it says in 10 minutes. So our X is 10 minutes. And so what we're going to put here is she can do 17 plates. So on the bottom in the fraction, I'm going to put 10 minutes. And then 17 plates. We want to get it to where she's at for 1 minute. How many plates can she do in 1 minute? Well, when you're looking at something like this, I like to put the X on the bottom and then the Y on the top. So I can divide the X into the Y. And so really what you can, when you see this, you're like, all right, I'm going to just divide 10 into 17 or do this. What it comes out to is 1.7 plates. So she can do 1.7 plates in a minute, right? If you talk about it, like if you gave her 20 minutes, she would do 34 plates. Okay, then we would graph this. So I'm just going to turn the page. And if you turn around and look at the graph right here, one of the things in math, in this year's math, is we want to graph well. So we make our graph, right? It's a little bit off for me, but we are really going to be using just this section. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you can just see, what did we say? We'll just do 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13. 13, 14, 15, 16, 17. All we're going to do is 1 and 1.7 is going to be like right here. And remember, we're going to start in the origin. Here's the origin, right in the middle, right? And then 10 and 17. And here's your graph. Okay. So here's that. All right, cool. So the next one is B, Yasmin's puppy. We're going to try to make this go a little bit faster here. Yasmin's puppy, right, when she was born, she weighed 14 ounces. So day 1, 14 ounces. So we write it here, and we also do another X and Y table. Day 1, 14 ounces. Day 10, let's go day 10, she doubled her weight. So she's going to be at 28 ounces, right? So that was a quick jump. So the X is days. Now they want us to graph it. Can we make a graph right here? Yes, we can. So we're just going to do this. Remember, the days are here. 1. Okay, and then let's do 5, 10, 15, 20, 25, 30, 35, 40. Because we're going to get to big numbers because this is doubling. Because if you were to do day 10 again, she would double in size, and this dog would be 56 ounces. All right, and so let's just do this is day 10 out here. And we'll just graph it like this. So day 1 is 14 ounces. And remember, we're starting here against the origin because this is proportional. Day 10 is here, and we're at probably 28 here. Yeah, so it's kind of like, remember, this is kind of going to curve because why? It's exponential. It's not linear, so it's really, it has a multiplier. That's why it's curved. Let's put curved means multiplier. Okay. All right, here's C. Let's just take a look at C. C is different. C says, Angel saw an internet pop-up advertisement for his investment that doubles your money every year. If Angel invests $20 of her grandmother's money that her grandmother gave her for her birthday, how much money will she have in various years? First thing we do, X and Y table. Now, this particular one is not going to be proportional. Why isn't it going to be proportional? Because you have to invest the $20 her grandmother gave her to get the money out or to collect the interest on the money. So that's what we're seeing. We're going 1, 2, 3, 4, 5. If you look, it's supposed to double each year. So the first year is $40. The second year is $80. The third year is $160. The fourth year is going to be $320, and then the fifth year is $640. If you were to graph this, here, let's just graph this really quick. We're going to be dealing with big numbers. And once again, when you graph this, it's going to curve, right? So here's your years, 1, 2, 3, 4, 5, 6, 7, 8, 9. We only went up to year 5. So we're going to do this. We're going to go 50, 100, 150, 200, 250, 300, 350, 400, 450, 450, 500, 550. So 0 and 20 is here, right? 1 and 40 is here. 2 and 80 is here. 3 and 160 is like right here. 4 and 320 is right here. And then 5 and 640. I didn't even make a spot 5. That's 550, 600, 640. So if you watch, it goes up this way. So this also, it's A, not a proportion. And then B, it's also a multiplier. It curves. Awesome. All right. So I'm going to do one last one. We're going to talk about Doug and Johnny. Doug and Johnny are two friends. And we're going to see who gets paid more. I'm just going to write Doug out really quick for you, and then you're going to tell me, or we're going to figure out. So for 6 hours of work, Doug gets paid $55. This is Doug. Johnny was bragging, and he was like, dude, I get paid so much more money than you. And they were talking about it. And if you look at the graph right here, if you look for 4 hours, this dude gets paid $50. So 0, 1, 2, 3, 4, 5, 6, 7. So $50. What we want to find is how much they get paid for an hour. So if we divide 6 into 55, please use your calculator. I'm going to use mine. 55 divided by 6 equals 9.1666. So we're going to say that Doug earns $9.17 an hour. Okay, and let's clear this out. Let's see. And so the other guy, Johnny, gets paid $50 for 4 hours. How much is that? That is $12.50 an hour. Okay, could you show this on a graph? Now the cool part is for this one, we can do it on our Desmos activity. So we can go right here. And we could start doing Doug's table right here. Let's make sure this full screen. Cool. So what you can do is click on the white circle. And so you can just start playing with it, and you can, when you start here, hold on, let me just move it over. You can start, let's get more into it. So here's 6 hours at $55. So when you find what Doug is, which is at 1 hour, he's at, this is 50, he's at like $9.10. Hold on. I'm not actually sure how that's going to work, but there you go. So this is basically the lesson for today. We really figured it out. I'm kind of going to leave it at this, but thank you, and I hope you enjoyed your little lesson.